Hello, everybody, and thank you for joining us for today's LinkedIn Live presentation of Speed, Scale, and Stealth, an attacker's account takeover tools or an obstacle, your choice. My name is Adam Sell. I'm Senior Research Editor at Human. And before we begin, I would love to introduce my panel today. Joining us is Frank Walsh, Field CTO at Human, and Samrat Karak, Senior Product Manager at Amazon CloudFront. I would love to kick it to you, Frank. Tell us a little bit about yourself. What's your background? What's your experience with the subject material? And perhaps most importantly, what is your favorite robot?
Oh man, Johnny Five's my favorite robot. We'll start there. My first computer was a 286, so the early days of computing and robots are my favorite. I am Field CTO here at Human. I've been building software and securing it for 20 years now. So I first spent about half my career writing software before really the cloud even existed, and then transitioned into the world of cyber with a great company named Tanium. Led teams at a few other startups here at Human. I've been for approaching 3 years now, and I'm head of the teams that consider how our technologies will help customers and help customers adopt them. So excited to be here today to talk a little bit about our tech and how it works with Amazon and how it helps people solve real problems.
Excellent. Thank you, Frank. And Samrat, tell us a little bit about yourself and your favorite robot.
Sure. I'll start with a favorite robot, and that's Atlas from Boston Dynamics, because Atlas can dance better than me. So that's aspirational. I need to learn some of those moves. In terms of my experience, I'm a senior product manager on the CloudFront team, which is the content delivery network for AWS. Within CloudFront, I currently focus on the edge compute services, which is both CloudFront Functions and Lambda at Edge, allowing developers to run code closer to viewers. Before this, I've spent about 6 years with CloudFront, where I've helped build and improve the experience for developers on CloudFront with improved observability, expanding CloudFront in new countries, as well as features such as real-time logging, among other features. And then before this, before moving on to CloudFront, I was part of the commerce platform in AWS, where I helped new services on AWS build their integration with the billing systems and launch quickly. Prior to my AWS experience, I've helped financial services build enterprise applications, as well as go to market with web applications to solve different types of problems, building mobile apps, all sorts of things on-prem. And then with AWS, it's how do we deliver these applications to customers with higher performance. And that's sort of what I focus on now.
Excellent. Thank you. And today we're going to be talking about how a few core AWS capabilities are used by application developers to improve how their applications work, and how, even beyond improving their applications, those same components can be used to protect an application from abuse by threat actors. Would love to dive in first with a question for Samrat. Could you help us set the stage for how customers are using CloudFront, CloudFront Functions, Lambda at Edge capabilities, and observability on CloudFront to improve their applications?
Sure. So when it comes to CloudFront, I mentioned CloudFront is a content delivery network. So CloudFront has edge locations, over 600 of them spread across the globe. And when customers try to build applications, CloudFront make sure that we are delivering the web traffic from these edge locations closest to where viewers are. And then, in addition to delivering traffic with high availability, low latency, we have these features of CloudFront Functions, Lambda at Edge, where based on the requirement, the website developers can introduce logic to to improve their application, sometimes improving the caching capabilities, as well as because this is edge compute, any sort of additional processing that a customer wants to implement as part of their web application. These are things that CloudFront enables. As an example, this integration with human with a CloudFront distribution, a customer can use Lambda at Edge and integrate with the human component to act on a request and allow or deny based on the parameters that are part of the request. And then as a customer is using CloudFront Functions, Lambda at Edge, we provide varied levels of observability, starting from metrics in CloudWatch, logs in S3, or real-time logs in Kinesis, uh, to observe what is the current state, alarm on them, as well as take action, based on understanding what is the current state of world in real time, if needed, as well as, there are other observability features such as reports that are available within CloudFront as needed by customers.
So let me follow up with you real quick and ask, do you have any kind of a framework by which you think about these capabilities when you're building applications?
Sure. When it comes to capabilities on CloudFront, we like to think about at least three main pillars of availability, performance, security. These are core pillars that we focus on within CloudFront, enabling customers delivering their applications on CloudFront. And because I own the Edge Compute roadmap, there's also the developer experience and how do we improve it. But then I'll quickly talk about each of these pillars. Availability refers to making sure a web application that is being delivered by customers is available, so that viewers accessing the web application can access this at all times. So high availability. Performance comes to making sure CloudFront is able to deliver the web traffic with the lowest latency possible, improving the experience for viewers, and then finally security, making sure that the application is secure, both in terms of restrictions on the origin that a customer has for their web application, as well as protecting the application from distributed denial of service attacks.
Now, Frank, I want to switch over to you for a second and ask if, from your perspective, attackers have kind of an alternative series of pillars
Yeah,
to improve their outcomes.
yeah, certainly. The same way, the pillars that Samrat was speaking to would improve any piece of software, whether it be accounting software or collaboration software, right? No matter what kind of software you're building, making sure it's available, that it performs quickly, and that it's secure are critical to that software being software, right? And so similarly, attackers have kind of evolved into thinking about their approach using their own set of pillars. And I like to use the alliteration speed, scale, and stealth. Really, speed is about how bots and attackers who are trying to attack your platform want to do so quickly. Why do they want to do so quickly? Because they want money faster. They want to take information faster. They want to achieve the end game of their attack, sooner rather than later. On the topic of scale, they want to do this more than one place, right? Like an attacker who is compromising or identifying compromised accounts through account takeover attempts. They want to do this on many sites or many interfaces. A lot of organizations have multiple login interfaces or multiple apps that, and even multiple modalities for an app, like mobile versus web. And then finally, no one wants to get caught. That's an attacker, right? They want to do this in a manner that allows them to continue doing it and protects them from, being prosecuted, right, or stopped, in the real world. So this is really, I think, when attackers think about the way they want to improve their attacks, the kind of same structure of the pillars that builders are thinking about that Samrat mentioned.
So then let's go pillar by pillar, shall we? Like, Samra, tell me a little bit about availability and how AWS can help an app developer improve their availability for their app.
Sure. So when it comes to availability, it's a number one area of interest for customers. As an example, customers ask themselves, how do we become more resilient and ensure high availability of our applications? And CloudFront has several native capabilities to ensure customer applications maintain their high availability. And I would say overall there are three buckets that I can talk about in terms of network, server or host, as well as software resiliency. Using these, CloudFront is able to ensure the high availability. Talking about the network itself, CloudFront has several traffic congestion control mechanisms, a whole redundant backbone connectivity with the broad AWS backbone. In case of because this is the internet, there can be network disconnections, and then we have resilient connectivity to offer that high availability experience, as well as flash cloud management. Sometimes in a real case, something, a website or a particular object gets super popular, and there's a lot of legitimate customers trying to access the same object. How do we handle it and ensure that the application is available? So those are things that CloudFront addresses at a network level. And then talking about the server or the host level, CloudFront has layer 4 load balancer, again to manage traffic at a packet level, and then fanning out of requests and auto scaling based on bursts in traffic coming from viewers, again ensuring the high availability that customers expect from CloudFront. And finally, the software resiliency. So even internally within CloudFront, we are constantly launching new features, making updates to existing capabilities, and we are deploying software continuously across all of our global edge locations, and making sure these are deployed in stages in different stripes, validating that the application as well as CloudFront is stable before propagating the changes, ensure that we offer that high availability experience to customers. And then finally, I'll just talk a little bit about these are things that CloudFront does, and then for CloudFront customers, there are certain features that we offer that allow customers to control availability on their side as well. And as an example, we have a feature for all origin failover, where when you are configuring your CloudFront distribution and you're specifying the origins that CloudFront should go fetch the content from and then deliver to viewers, providing the primary as well as secondary origin, CloudFront will fail over to the secondary origin if the primary origin is unavailable. Those are capabilities that CloudFront offers to customers to control availability. And then I talked about continuous deployment. Continuous deployment is also a feature that CloudFront offers. So if you have a web application and you're making changes, maybe changing some settings on CloudFront, but you want to test it out on a subset of customers, CloudFront lets you run these sort of phased deployments using the continuous deployment capability.
Excellent. Thank you, Samrat. And Frank, let's flip it around. Can you share a little bit about how achieving availability goals with AWS combined with the use of human solutions can improve an application?
Yeah, I think like relating this to the pillars and attacker things about, for me, this is a question about how attacks scale and how that impact of a scaled attack, can damage an application, right? Like Samrat shared a lot about how, availability goals are about keeping applications online and making sure they can be used by real humans. When in I think it was 1999, there was the first DDoS attack occurred, and it was at a university, and a bunch of computers basically attacked a service, and in doing so took that university offline for a few days. And at that time, I think it was like hacktivism, right? Like just people trying to see what they could do and how much control they could have over these big internet systems, or these emerging internet systems. But attackers really kind of quickly pivoted toward first finding ways to monetize the idea of denial of service, threatening organizations, say, if you don't pay up, I'm going to take your application down. And then they even evolved to like where I think denial of service is actually a symptom. It's not the illness, right? The illness is an account takeover attempt that overloads an application. And so as application architecture has evolved, and we've taken like these monolithic apps and like subdivided them into services or microservices, or distributed them using technologies like a CDN, we've basically seen the landscape that can be targeted by attackers grow to include that CDN, or if that CDN can't defend the attack, it reaches origin. And then we again have this scenario where a bunch of computers, your own CDN, are impacting and damaging the origin infrastructure that's like consolidated behind it. And so really, this is where I think it's great for technologies like Amazon, CloudFront, and Human to really combine forces and ensure that that edge serves as not just a way to make sure your application is available in different regions, or make sure it can always respond when it's under real user load, but also serve as a protective shield, barrier, and really a unified kind of moat to the abuse that an attacker might try and direct toward an application. So a lot of really powerful things can be done when you turn the edge not into just something to improve the architecture of your app, but to shield your app from abuse.
Excellent. Thank you, Frank. And before we jump into the next topic here, I just wanted to remind those of us joining us right now that if you have any questions for either of our panelists, please feel free to drop those in the comments here on LinkedIn Live. And if we've got some time left over at the end of the presentation, we'll be sure to address those comments. Moving on to the next pillar, though, Samar, can you tell me a bit about performance? I think that was the second pillar that you mentioned, and what performance goals AWS customers, are working to achieve.
Yeah, when it comes to performance, it matters to customers that are delivering their applications, because studies have shown that there is a direct relationship between the response latency and user engagement, and in some cases, milliseconds can meaningfully improve the user engagement. So, performance being an important criteria for customers to deliver their applications on CloudFront. CloudFront helps improve the performance by firstly delivering the web application traffic, from the over 600 edge locations in over 100 cities globally, delivering the traffic from the closest edge location where we think the viewer is based out of. And then, in addition, there are several sort of native capabilities of CloudFront, such as, the congestion control. Recently, we added support for BBRv2. And we observed that with congestion control, the performance improved and the latency reduced for customers and viewers, based out of networks with a lot of mobile traffic and heavier network congestion. Similarly, in the last year, CloudFront announced the support for HTTP3. And we observed that customers, again, predominantly mobile users, the time to first byte also improved by up to 25%. And then, talking about performance and how, for example, if you have customers with video traffic, better performance improves the quality of experience for viewers with minimal interruption during playbacks, and overall better experience for the viewers. And so even within CloudFront, we have several configurations and capabilities, such as on CloudFront, customer can configure a cache policy to say what are the parameters that would be part of a cache key. What are request parameters that should flow all the way to the origin for the origin to make decisions on the type of response to send back to CloudFront, and then certain capabilities, such as stale while revalidate, that allows CloudFront to serve content that may have exceeded the time to live that a customer configures, but then revalidate while serving this content and fetch the latest data from origin. So these are different mechanisms by which CloudFront can ensure that we are delivering high performance, low latency for the customer traffic. And I'll quickly mention that in addition to these capabilities, customers can also use edge compute. So both CloudFront Functions and Lambda at Edge to improve the performance further. For example, customers can use edge compute to normalize query strings, URIs, headers, to make sure that requests for different objects, if the query string, let's say, is normalized, then we are caching a lot more of the traffic, and then this can be observed using the cache hit rate metrics, because to improve the latency, broadly speaking, you need CloudFront to deliver cache content at the edge and deliver from the edge locations. And then there are all these tools available to CloudFront customers to improve the cache hit rates on CloudFront.
Then Frank, help me understand this from the attacker's perspective, because this sounds an awful lot like a conversation about speed. Can you tell me a bit about how speed really benefits a threat actor and makes what they're doing more effective?
Yeah, absolutely. So, we build apps using technologies like Simrat shared to improve the performance for all users. And that includes the bad users that unfortunately they're included in that, experiencing that advantage. And as applications become more performant, clearly, I'm sitting here in front of the keyboard and mouse, and I can promise you, like, when an attacker is trying to fuzz, which is the process of delivering exploit payloads, they don't hand type them. They script them to be repeatedly delivered. If you're familiar with a tool called Burp Suite, there's a full function in Burp Suite called the repeater, which is essentially a bot. It repeats delivery of payloads until it figures out which one worked. Attackers use the same approach when they're delivering stuffed credentials. They're seeing if one set of credentials works or one password works, and then they're iterating, trying to crack a password, or they're trying a new set of credentials that they got from a dump or a phishing attempt. And so, like, long story short, attackers are very, very aware of, like, hey, that didn't work, I want to try again. Hey, that didn't work, I want to try again. So the name of the game for an attacker is how quickly can I try again? And so, like, this is one of the major problems that surfaces as you speed up an application. You offer that same speed to attackers, and you also offer, additional landscape for an attacker to abuse. For example, if they're performing scraping, now they could potentially retrieve portions of what they want to scrape from different edge pop, servers or, infrastructure. And so they can distribute that attempt to not just rely on faster response times from one server, but now they can distribute it across many, many servers globally. So I think it's really important that technologies like CloudFront, combined with technologies like Human, really make it much harder for an attacker to repeat an attack over and over again, or to distribute an attack across many POPs. Really, when Human is embedded within CloudFront, Lambda at Edge, we have the ability to kind of see how all the POPs are reacting, or how one or many origins are sharing characteristics across the device connected on the other side, or the accounts that are being used across a pool of requests. So it's critical that security plays a role at the edge and inside these technologies, ensuring even the computation, the normalization, the data that's the result of this cloud edge runtime, is secure.
And that's a great segue, Frank, because I believe, if I'm not mistaken, the third pillar that Samrat mentioned earlier in the session was security. So let's jump right in. Samrat, can you elaborate?
Sure. Security being a very important pillar of CloudFront, there are various categories of security that we refer to. Especially when it comes to the customer application. For example, CloudFront comes with native DDoS protection in the form of Shield Basic, and customers can opt for advanced layer 7 protection with Shield Advanced. But I'll just talk a little bit about DDoS protection, and then moving on to other types of security features that CloudFront has. So, example of DDoS events can include HTTP request floods, reflect amplification attacks. For example, recently in August of this year, we detected an unusual spike in HTTP2 requests to CloudFront, which peaked over 155 million requests per second. And because of this, DDoS protection that we offer to customers, we were able to act on the DDoS, protect our customers from it. And, this was all done behind the scene. Customers did not have to, worry about this type of attack that we help protect customers from. And then I think moving on from DDoS, there are other capabilities such as, TLS using certificate management. So CloudFront is integrated with ACM, AWS Certificate Manager. If customers want to configure custom certificates on their website. And then, I talked about the origin protection. So customers can configure their CloudFront distribution to talk with the origin. So as an example, if a customer has a S3 bucket, we have multiple capabilities, origin access control, that will ensure that only the customer's CloudFront distribution can talk with the origin, protecting the origin from any external access, and just supporting the access from the CloudFront distribution. And then talking about other security capabilities, CloudFront has a native capability of geo restrictions, or implementing, even granular restrictions using CloudFront functions. That's a capability that customers have. And finally, using edge compute. So I talked about geo restrictions, but edge compute, both CloudFront functions and Lambda at edge, can be used to evaluate various parameters of an incoming request, and then make a decision whether a customer wants to allow or block that request. These are available with CloudFront, and then there is an integration with WAF that allows additional rules that can be applied on a CloudFront distribution. But overall, there are series of both capabilities that CloudFront offers to customers to configure, as well as things that CloudFront is always working on behind the scene to ensure that customers' application is secure and protected.
And Frank, can you tell me a little bit about making sure that we have not just a real human that's visiting a given application, but also the right human? How does stealth really benefit a threat actor?
Yeah, thanks, Adam. Well, I mean, I think it's reasonably obvious attackers don't want their attacks interrupted or shut down, right? Once they start an attack, they're like, I want all those email addresses and passwords I have to be tested, or I want all that information I'm trying to scrape, right? And so that's really kind of the most basic thing that attackers want. But more importantly, attackers don't want to be caught, right? They want to basically make sure that there's no repercussions for their attacks. So I think, there's a bit of this game of cat and mouse where, you start blocking IPs and attackers start using VPNs or infected devices to distribute their requests, or even sometimes cloud compute to distribute their requests, right? And so what do we do then? Well, we have to find ways to identify the accounts, right? We, in this game of cat and mouse, we're like, okay, well, if IP doesn't matter, let's try and identify all the bad accounts. But then a lot of times resources are available pre-auth, right? And services are part of even the process of eventually reaching an authorized state, like account signup, for example. And these are even services that attackers abuse and try and monetize. We've seen a lot of attacks where attackers have no idea what they're going to do with the accounts they create. They just create a bunch of them and they go sell them to somebody else that maybe 6 months later figures out some way to go use them to do something that we wouldn't want them doing on our app. So I think, what's important is to look at how the edge can be extended into the connected device and the analog to digital, the keyboard, the hands-on keyboard, the real human typing, or maybe not the real human typing. So that's really like a higher fidelity way to decide whether or not we should trust a request, not waiting for it to show up in our mailbox, actually having opportunity to witness the person writing that request on the other side using technologies like humans. So when we're embedded into edge capabilities at CloudFront, we can basically help make the decision as to if to shield this request or allow this request. We can make it more about what happened even on the receipt sending side than just what shows up at the CloudFront perimeter or edge. And so, all this really adds up to a better more performant application, an application with less junk or abusive content, more real and good use. We are all able to surface it in Amazon platform capabilities like CloudWatch, really opening the picture of what we're seeing, into the not just the DevSecOps lifecycle, but even a product team's consideration of what they want to do next as they enhance their app.
Thank you, Frank. And we are rapidly approaching time on this LinkedIn Live, but I think we've got just a couple of minutes to ask some questions from the audience here. The first one, I think, Frank, I'm going to kick this one to you, is what are some of the strategic defense mechanisms that defenders can activate?
Yeah, sure. So like beyond, the whack-a-mole game that you can play blocking IPs, there's this idea that we can challenge a user. And there's been a lot of jokes and funny commercials where they're, no more robot tests. Like, how hard can it be for a computing technology like OpenAI's ChatGPT to find crosswalks or chimneys or flip cats up right side up, right? So really, we need to find and use ways to challenge attackers that are more permanent, that introduce more repercussions to them should they continue their attack. And this involves identifying who's behind an attack. This involves shutting down attacks in a way that is harder to persist. And this involves challenging the device in a way that's hard for automation, but easy on humans. And this is really where human is an expert. And we've done a lot of work over the last decade to make sure we're delivering something really powerful. So super excited to be able to offer those capabilities, and make it much harder for attackers with Amazon.
And we've got time for just one more. So, Samar, let me ask you this one. How can somebody monitor their current setup with CloudFront and Human?
Sure. So first, I'll talk about the CloudFront aspect of it. When a customer is configuring CloudFront and Human together, there is, requests that are landing on CloudFront being delivered by CloudFront, and then there is Lambda at Edge, and finally requests as part of Lambda at Edge being routed to Human endpoint. CloudFront requests on CloudFront as well as on Lambda at Edge are all published to CloudWatch. So there are dashboards that customers can create on CloudWatch to both review as well as alarm on the metrics that are available. So this is the metrics aspect. And then there are logs. So Lambda at Edge logs are also available in CloudWatch logs. So easy for customers to either create dashboards or query the logs within CloudWatch logs. And then CloudFront offers two flavors of logs: the standard access logs in the S3 bucket, as well as real-time logs where customers can, out of 40 plus fields, select for every HTTP request that CloudFront delivers, select the fields that customers care about, would like to monitor, and then CloudFront delivers those logs to the customer's Kinesis data stream endpoint that customers specify. So this is from the CloudFront perspective, seeing how to monitor data. And then, Frank, if you want to take up the human aspect of monitoring, go for it.
Yeah, so we certainly expose a lot of really powerful information, actionable information, forensic information that can be investigated through our platform to help security practitioners decide what traffic to allow and what traffic to deny, what accounts to shut down. But we recognize that really, I think Amazon customers are in pursuit of a single pane of glass. They want all of the information from all the components of their application in a single place, so their decisions are not made with only a single dimension of focus or kind of precision. And so really where human has a powerful capability is in delivering this information in real time to CloudWatch and helping CloudWatch understand how it fits together with other information that's in CloudWatch. And so this really gives an entire DevSecOps or SOC operation the ability to look holistically at what human sees and how it relates to all the other powerful capabilities that are within CloudWatch.
Excellent. Thank you both. I think that's about all the time that we have for any questions during today's LinkedIn Live session. If there's any questions that we haven't gotten to, I apologize that we've run out of time, but we'll be sure to follow up with you later. And that includes anybody who's asked any questions after this live session has ended. Please stay tuned and we'll be sure that somebody is able to follow up with you and get you an answer to the question that you've asked. Want to thank everybody for joining us today, especially our two panelists, Frank Walsh, our field CTO at Human, and Samrat Karak, Senior Product Manager at Amazon CloudFront. If you have any questions about how we can help your business, feel free to reach out via humansecurity.com. And thank you all so much for joining us today. Have a great day, everyone.